Good day to you from Chem Help ASAP. This is a reaction video. It's a reaction to one of NileRed's older videos from 9 years ago. The video is entitled Extracting Lidocaine from Anal Lubricant. Although it's an oldie, it's definitely a goodie, so we'll take a look. It's a fairly simple process. It's just an extraction of an ingredient from a consumer product.
Lidocaine is a pretty potent local anesthetic that has a lot of different applications. The most familiar use is probably the use by the dentist to numb your teeth.
Now before he leaves this image, see that bottle? That is an old chemical bottle where he has used the reagent, he's cleaned out the bottle, and now he's using it to store different things that he's made. Almost all chemists do this in some fashion, but chemical suppliers, they supply their products in these nice amber bottles, typically to protect the product from light. And it's nice to be able to store the stuff you make and the stuff you gather in these same kinds of bottles. So labs are full of these reused bottles very often.
It's also used in other things like creams and topical ointments for minor pain relief. In this video, I'm going to be extracting some lidocaine from an over-the-counter product, but in a future video, I might synthesize it from scratch. If you're interested in knowing more details about local anesthetics...
So this is a little baggie. I'm hiding with my image. It says benzocaine, so that's a little baggie of benzocaine. I like this baggie. This is not your typical Ziploc sandwich bag. This is kind of a, lunchbox snacks kind of bag. We only have the sandwich bags in my house. It's kind of an interesting size of a Ziploc bag.
General and just a little bit on how they work, you should check out my video on the synthesis of benzocaine.
I'll try to put a link in that in the video description if I can find that video.
I was going to be lazy and copy paste my intro from the other video, but I decided it's better if I just link back to it. Anyway, without further stalling, we can get on with the extraction.
Oh yeah.
For this experiment, you're going to need some maximum strength anal lube by Passion.
Okay, he's going to give us 2 reasons why he chose this specific product, and these are going to be important details.
This is the best product for extracting lidocaine because it has the highest concentration of 5% and it has no emulsifiers or surfactants. Okay,
so it has a high concentration of the active ingredient, in this case that's lidocaine, and 2, it doesn't have a lot of other substances. It doesn't have a lot of emulsifiers or other things that are added as inactive ingredients that make the extraction difficult. So he's chosen this carefully, and he'll kind of give references to why he chose this again later in the video.
Nicely enough, the only chemical that's required for the extraction is sodium hydroxide.
Now, before we leave this image, I don't know if you can see at the very bottom of the image, it might be kind of blurry, that is 8.25 fluid ounces or 244 milliliters. So that's the amount of material in that bottle of this lubricant. This is this probably has a density pretty close to water. So if it has 244 milliliters, it probably weighs about 244 grams. And so that's going to give us a comparison. How much did we start with and how much did we actually extract the lidocaine? And that'll just give us a sense of how efficient this process is. He said this is 5% lidocaine. I found some evidence that this used to be made in 5%, but when I look, I also find 3.5%. So I'm going to assume NileRed knows how to read the side of a bottle and that it is 5%, but you may or may not be able to buy this exact product today as you could 9 years ago.
To start out, we fill a beaker with a little bit of distilled water. Then we add pretty much an arbitrary amount of sodium hydroxide to it.
It's not arbitrary. He's got a feel for how much he wants. It's not totally arbitrary, but he's got let's call this 10% sodium hydroxide solution in water.
Then, using the magnetic stirrer, we stir until we get a nice clear solution. Dissolving sodium hydroxide releases quite a bit of heat, so by the end the solution might be steaming a little. We then open up the brand new, never before used bottle of lube and pour it into a beaker.
Why is it important that it's never been used before? Because that way we can say whatever it says on the bottle, 244 milliliters, then presumably that's the amount of material that's going into that beaker. So that's important. And I will note that there is a chip on this beaker. Try to avoid using chipped glassware. Listen, I do it all the time, but it's generally, you can cut yourself and stuff. But you will almost never see NileRed use chipped glassware. I guarantee you in his new videos, he uses nice, pristine stuff. But there is a chip in that beaker.
You can see it's pretty goopy, so I squeeze the bottle and I do my best to get out as much as possible. However, no matter what, there's always going to be a little bit left in the bottle, but that's okay because we'll wash it a few times.
Okay, that is some thick stuff. It is hard to get out of the bottle, but he's gonna get that material out. He wants to get a quantitative transfer. All the content that's in that bottle, he wants in that beaker, so he can get the maximum amount of material out of here. Look, and he's careful when he pulls it away. He don't want stuff dripping off the edge of that bottle, because then when he pulls it away from the beaker, it's going to drip all over the place. He wants everything to get into that beaker, so he's being careful with it.
So we pour in some distilled water, cap, and then shake it vigorously. This might produce a little bit of foaming or bubbling, but that's okay.
Kind of an unstated idea is that this stuff is water soluble, so he can rinse this bottle out with water, and it won't mess up the material he's using. So as long as it's water soluble, any residue he can just rinse out of that bottle.
Once it's been shaken and thoroughly mixed, we can uncap it and add it to the rest of the lube. I did a second washing just to clean the bottle as much as possible, but at this point it was already pretty clean.
So did he get 100% of the material? Probably not. But did he get over 99%? Probably so. So this is, everything can't be 100% complete. There's got to be a point at which you say, it's good enough. Good enough is not a bad thing. That's not a loser mentality. Good enough is a practical, we have to move on. And he's made the decision, it's good enough, let's move on.
You can see the more watery top layer is just floating on top of the thicker lower layer, and when I turn on the stirring, the bottom layer kind of just bubbles up.
It is thick. Let me fix my lights. There we go. Okay, it is very thick, and so that stir bar has a hard time getting things mixed up. This will mix in. It just takes a little bit of time.
Even if the beaker is lifted up and shaken manually, it doesn't really mix all that well. To get it to all be one homogeneous mixture, we need to add more water.
Now listen, I'm not looking at this material in real life, and NileRed is, but my suspicion is that it's not a homogeneous mixture, it's that it's still so thick, there's not a whole lot of water in there, and therefore it's still quite a thick material. And as you swirl it around, you trap bubbles in, and the bubbles just make it so you can't tell what's going on in there. So he's adding more water, that's thinning out the mixture, and so that'll allow all these bubbles to get out, and it'll appear to be homogeneous, because it is homogeneous.
I topped the beaker off to about halfway, but the amount of water that I added was pretty arbitrary. We just need to add enough to get a uniform solution and not 2 layers. As the bubbles start to clear, you can see we don't have any layers anymore, and just for good measure, I test the pH, and it seems to be around 7.
Okay, so this is pH 7. That's not surprising. People who use this product, they're presumably going to put it on sensitive areas, and so you don't want things that are wildly different from a pH 7, things that are acidic or caustic. So this material likely contains buffers that make sure, when they make the product, they make sure it has a pH of 7 so it doesn't irritate your skin. And that's exactly what he's finding. He mixed it with distilled water. That won't change the pH. And so he's seeing it gives a pH of 7.
So at this point, we can start to add the sodium hydroxide solution that we made earlier. You can see that the moment that it's added, a white precipitate crashes out, and this is our lidocaine. What we're doing here is pretty simple, and we're effectively just freebasing the lidocaine.
Okay, so I'm going to put on the screen a description of what's happening here. So this is the lidocaine at pH 7 will actually be protonated. It exists as a salt, and that's an ammonium salt. And as you add base, that base will deprotonate anything that's acidic in the solution. In this case, eventually it'll get around to deprotonating the lidocaine, and that forms the free base of lidocaine. And it turns out that is not water soluble. And although this is not a pure water solution, it's mostly water. So under these conditions, the neutral lidocaine, the free base, precipitates out. And so you start to see it precipitate in here. Note that there are other substances in here that could be acidic. And so he might need more base than just the base required to neutralize the lidocaine, because there are other things that can also react. So he's adding a decent amount of base in here to get this to occur.
For the lidocaine to be soluble in water-based lube, it needed to be the salt version, lidocaine hydrochloride. This salt version is very water-soluble, but it's also slightly acidic. So this means if we add a base to it, we can neutralize it. When this salt is neutralized, we'll get free-base lidocaine, which is extremely insoluble in water.
So he's just mixing this around as he adds the base. He wants to make sure that he is increasing the pH. So he's adding base. Base has a high pH. And so the more he adds, he's monitoring the pH to make sure it moves the way he expects it to.
So I keep adding sodium hydroxide and testing the pH until I get to around a pH of 14.
So he's gotten to a pH of 14. That is a quite high pH. This is definitely on the basic end of the scale. Notice he does have solids in there. As he swirled this around, some of the solids have kind of slopped up on the side of the beaker. That's okay. He's going to be able to get them, but there's definitely solid in here.
Once the pH of 14 is achieved, almost all of the lidocaine should exist as the free base. And now, the lidocaine can be isolated by vacuum filtration. I would say a vacuum filter is really necessary for this because gravity filtration would just take forever.
Why would gravity filtration take forever? Well, remember that this does still have all those thickeners in here. Although it's largely water, there are a lot of these thickening agents, and those thickening agents would kind of gum up filter paper and make the filtration go slowly. So the vacuum filtration helps things go a little more quickly.
Eventually, most of the water is gone, and we're left with the lidocaine at the bottom, but it's a little gooey. To get rid of the gooiness, we just wash the lidocaine a few times with some distilled water.
That gooiness is the thickening agent, and that is a cellulose product. It's water soluble, and so he's just rinsing that thickening agent, any residual that's on his solid, to get it off there. Rinse that with water. And that should carry that thickening agent into his receiver flask and get it away from his lidocaine product in the top of the funnel.
With each washing, we stir thoroughly using a glass stir rod to break up any large chunks. After washing it a few times, the lidocaine is definitely cleaner, but it's still a little bit gooey. For now, this is okay though, and I transfer the lidocaine blob to a beaker. And then we pour in more of the lidocaine suspension and filter it off.
So he's doing this in batches. He's getting some out of his precipitate solution. He gets some, he then does a rinse, pulls that out of the funnel, and then he does some more. So this is probably a pretty tedious process. Probably took quite a while to do.
We do it exactly the same way that we just did it, and we keep repeating it until everything in the beaker is filtered. We keep doing this, and we're left with a decent amount of wet lidocaine. So with all of our lidocaine in the beaker, we add some distilled water to try to clean it up a little. We mix it around to try to break up all the large chunks and try to get rid of all of the water-soluble stuff.
Okay, so he skips some time ahead. You can see now there, he's definitely getting solid around this beaker. I mean, it's unavoidable. It's going to happen. But it does look like it's a little more, less lumpy and more free-flowing as a solid.
So eventually most of the large pieces are broken up and we're ready to filter it off. It's transferred back to my nice fritted filter and the water is vacuumed off. To this, I then add a little bit of distilled water. Then, just like I did in the beaker, I mix it around and try to wash the lidocaine. When the lidocaine is free of all the water-soluble stuff, it should be a free-flowing powder, whereas right now it's kind of clumped up.
Okay, he's done a lot of work on this, but he doesn't like how it feels on that spatula. So, that's just kind of a chemical intuition. This is good, but it's not quite there yet.
After I think I've done a decent washing job, I vacuum off the water. Then, more water is added, and I keep repeating this until I feel it is clean. After several water washings, you can see that although it's still not perfect, it's a lot more powder-like than before. There are some little bits that stick together, but overall I would consider this a powder.
Okay, I agree that it progressively improved. And so, again, is it perfect? No, but is it good enough to carry on? And he's made that decision, looks good enough.
So now we have some free-flowing lidocaine freebase, and it looks pretty clean, but actually looks can kind of be deceiving.
Okay, let's pop back on that a little bit. More frames. To me, it does look good. And he doesn't say this, but I suspect he maybe tried to carry this ahead and found he ran into problems. So somehow he figured out that this is not good enough, even though, by my eye, it looks great. And he even said it looks good. So somehow he did some searching to figure out how to make this even better.
Deceiving. To clean it up, we add it to a beaker and we drop in a stir bar.
Yeah, to clean it up. Looks good. Well, what is there to clean? But he knew something is not right here.
Then, using a squirt bottle, I add in ethanol until all of the lidocaine dissolves. Lidocaine is extremely soluble in alcohol, so it really shouldn't take a lot to dissolve everything. As I kept stirring, things were dissolving well, but you'll notice this black clump that's floating around.
Yeah, that is crazy. And he says he doesn't know what it is.
Honestly not really sure what this is, but it's definitely not lidocaine.
Okay, he added ethanol. Lidocaine dissolves in ethanol. That does not dissolve in ethanol. That is not lidocaine. Now, these personal products, they can have all kinds of stuff in there. There's xanthan gum. There's potassium sorbate in this according to the ingredient list. I don't know what that is, but it's something that was already in that mixture. So as it turns out, that something was also insoluble in water, so it precipitated with the lidocaine, and now he's able to remove it because whatever that impurity is, it's not soluble in ethanol, so now he can get rid of it.
Once everything's dissolved, we set up a quick gravity filtration using a funnel and a cotton plug. We then filter through all of our ethanol lidocaine solution.
And when he said everything dissolved except for that clump of, hairball or whatever that was. So he's going to remove that in this filtration step.
The cotton plug, the beaker, and the funnel are all washed thoroughly with ethanol to make sure that no lidocaine stays behind. Then with stirring, we squirt in water to crash out the lidocaine.
Now remember, we isolated the lidocaine initially by adding water, and the lidocaine precipitated. Well, now he has it dissolved in ethanol, and he's just going to flood it with water, and he's going to get that product to reprecipitate. And now he shouldn't have whatever those impurities are. This should be a cleaner product at this point.
The more water that we add, the less and less soluble the lidocaine will be in the solution. In theory, if we do this really slowly, we can probably grow some pretty nice crystals. However,
this is almost like a titration where you're adding the acid or whatever to change the pH. So what he's adding water to change the solubility, and eventually he's going to have enough water that his product is insoluble. So it's very much like a titration.
However, I wanted to go quickly, and actually surprisingly, even when you go quickly, you still get crystals. Eventually, upon one of the additions, the solution will get cloudy. The cloudiness means that there's free lidocaine floating around, but the concentration isn't high enough for it to form any crystals.
So initially, when you precipitate things out, especially in water ethanol solutions, you tend to find that organics will oil out. And so you get that cloudiness, but those oils have to coalesce and interact with each other to form crystals. And so that's what he's referring to.
That's okay, and we'll just keep adding water to increase the amount of lidocaine that's crashed out. And as we do this, eventually crystals will start to form like you see here. At this point, I kind of just went crazy and poured in a bunch of water.
This happens. It gets tedious just to add dropwise, squirt, just dump it in and let's end this chase. And I just cut them off, and those do look nice. They look like nice plates. That's a nice looking product.
With this large addition, we're left with a relatively clear solution with a lot of crystals floating at the top. These crystals are then separated from the water by transferring them to a nice clean fritted filter. The water is vacuum filtered off, and just like before, we wash the crystals a few times with water. Each of the water washings is also used to wash out the beaker to make sure that none of the lidocaine stays behind in it. Finally,
I'm going to go back on that. I love that look where you have solid sticking to the glass, and then you rinse it down to push it down with all the other product. Let's go back a few seconds. We'll let this filter through.
None of the lidocaine stays behind in it.
Let me fix my lights. There you go, squirting it down.
Finally, we wash the sides of the filter using a little bit of water, and we let the lidocaine dry by pulling a vacuum on it for a few minutes. What we're left with is some very nice, slightly wet lidocaine crystals. I laid out the lidocaine and I just let it dry overnight in air.
Okay, he let it air dry. Now, he's gonna, I don't want to steal his thunder much, but sometimes you heat stuff up to get it to dry. And so, why wouldn't you do that here?
In the morning, I was left with some pretty dry lidocaine, and when I weighed it, it came out to be about 6.5 grams. Unfortunately, I didn't weigh the lube before I used it, so I don't know what the theoretical yield is.
Okay, well, let's think about this. So, we know that there were 244 milliliters in that lubricant bottle. And so let's assume we have a density of 1 gram per milliliter. So that's 244 grams. If that is 5% lidocaine, then I thought I had it written down here. I don't. Okay, I wrote it down differently. So 6.5 grams out of 244 grams is 2.6% of the weight of 6.5 grams is 2.6% of the weight of that 244 grams. So he's recovered 2.6% of the material. Now, presumably it started at 5%. So he has lost some material, but I would say getting about half the lidocaine out of that soup, that's pretty good.
Anyway, 6.5 grams is more than enough for me. It's really important that you just let it dry it in air because it has a really low melting point, and if you try to dry it in an oven, something like this will probably happen.
Okay, so I said, why wouldn't you heat that up? Because very often you do heat stuff up to drive off water. Well, apparently he did, and he found out that's not a good idea for this. So, that's voice of experience. He tried to do what people often do, and turns out you got to let this air dry.
The method that I showed in this video might work on other products that contain lidocaine, but I can't guarantee it. I did try it on a few others, and none of them worked, and on top of that, all of the ones that you can easily get from the store will probably have a maximum concentration of 1%.
That language makes me think he was ready to do other videos on this on other products, but they didn't have high enough concentration, or they had other junk in them that made the extraction difficult. So he is alluding to some trial and error to get this video out. So it took him a while, apparently, to find the product that really worked.
To make the extraction the most time efficient, you really do want to work with the highest concentration possible. Also, the biggest tip that I can probably give is don't try to do any extractions using organic solvents. I've tried this, and it really just makes impossible emulsions that never separate.
I've tried this. How many extractions did he have to try to bring this video to fruition? I'm glad it got a lot of views for him, because it certainly sounds like it took a lot of work to find one that worked and was consistent in his hands. Anyway, that's it for now, and I'll see you on the next one. Okay, that was great. NileRed, again, thank you for a wonderful video. Great instructional purposes. Thank you for your attention. And if there's another video you'd like to see me react to, please let me know in the comments. Otherwise, take care.